next speaker is from Airware. It's Jonathan Downey. He's a good guy. He's actually been kind enough to come and speak this is the third year that he's been here to speak. And he always has something good to say. And last year, your presentation was like the most downloaded presentation. And it was advice for people who are starting business. And even I was over there taking notes going, oh, God, these are good. It was really good stuff. Please welcome Jonathan Downey. You don't have a clicker, though.
Okay.
You can mark it there, right?
Yep. I know you're all clocking me on how long this is going to take. How did I do? Yeah, thanks so much, Patrick, for having me again. As Patrick mentioned, this is my third time speaking at the Expo. It's an exciting event for me because I know a lot of us are here either starting our own business, thinking about starting our own business, a few years into our own business, and it's great to meet a lot of you and swap ideas and share thoughts on where the industry is going and where the industry is at today. I started Airware 4 years ago next month. And the company's been growing a lot. We've been focusing on building a operating system for commercial drones to really enable drones to be used for a lot of different enterprise and commercial applications. And today I'm going to talk a little bit about how drones are being used for different enterprise applications, what the perspective is of a lot of the enterprises who are looking at deploying drones at kind of greater and greater scale, a couple different applications. Last year when I spoke at the event, part of the reason I spoke about entrepreneurship and aspects of starting your own business was because our product at Airware was not yet released, and so there was only a limited amount that I could show about it. So today I'll touch a little bit on what the Airware platform actually looks like and actually walk you through a very quick demonstration of it and talk about where there's opportunities for companies, for those of you who are in the audience who are thinking about starting a business or who are just starting a business, different areas where I see some major opportunities for other companies to build critical parts of the ecosystem. So first, here's a quick video. Our product now is deployed with a number of different customers around the world. Here are some of their vehicles flying at a recent demonstration that we did. The platform works across multi-rotor vehicles like the Altavian vehicle, Allied drones, Delta drone. It also works on fixed-wing aircraft like this aircraft from UAS USA. It has a couple key components. One is a piece of hardware that gets installed onto the vehicle that runs our operating system software on the vehicle. It's also software that's running on the user tablet so that people can plan missions, monitor the aircraft in real time, and then it's a cloud backend for aggregating the data being collected by drones as well as managing the workflow of deploying drones at kind of greater and greater scale. One of the applications that we're really interested in and that we're seeing a lot of interest in deploying drones as part of the solution is cell phone tower inspections. This is an application that is, I think, a no-brainer to be using drones for a number of reasons. First of all, there's a lot of cell phone towers. There's about 4 million of them worldwide. With a drone, you can inspect 3 times as many in a given day as you can by climbing up on ropes and harnesses. Or by using scissor lifts, or by using any of the mechanisms that people are using today to do this type of inspection. And so a lot of business value in being able to do these inspections more rapidly and at greater scale. A lot of these inspections in different countries are mandated by law to be inspected anywhere from typically 2 times a year, but a lot of the companies are actually inspecting them much more frequently, either when new equipment is being installed or in anticipation of new equipment being installed, or if there's any disputes. The towers are often owned by a separate company than the companies who are installing equipment on them, who lease the property out from the tower owners. So there's all kinds of cases where what you really need to do is quickly get an assessment of what is installed, where is it the equipment people said they were going to install, Is it damaged? Is it up to date? And so doing this at greater scale has a lot of business value. But it's also one of the most dangerous jobs in America. In fact, OSHA said that there were 14 deaths by tower climbers in North America alone in 2013, and it was ranked the #1 most dangerous jobs in terms of accidents and casualties per 100,000 workers. Another use case is power line surveys. And power line surveys really exist at a great scale as well, with millions of miles of transmission and distribution lines. Sorry. Millions of miles of transmission and distribution lines that need to be inspected on a regular basis as well for things like vegetation encroachment, corrosion, damage assessment. Tree-related outages remain a significant threat to the delivery of electricity, especially as you're talking about lower voltage distribution lines and the closer that the electricity gets to the home. And it's one of the largest maintenance expenses that large utility companies have. PG&E, for example, spends $168 million a year managing the encroachment of vegetation on the power lines. So to the extent that that can be automated, can be done at greater scale, can leverage automation, enormous business value and impact by leveraging drones to be part of that solution. Today, a lot of these are being inspected by manned aircraft, including fixed wing and helicopters. They're also being inspected by people driving around in trucks and on four-wheelers and looking up at where the vegetation is encroaching, and to the extent that can be automated and only send people out to where the vegetation really needs to be cut back. A lot of business value. So we've all seen a lot of incredible visual images and videos that can be collected by drones, like this one of some farmland. But at the end of the day, enterprises need a lot more than aerial imagery and an aerial perspective. Enterprises need solutions. And there's a couple key things that we've heard time and time again consistently from different enterprise companies as they're looking at deploying solutions that leverage drones. The first is that they need solutions that are reliable and repeatable. It's not enough to go and demonstrate the business value or the ROI or the value proposition one time at a cellular phone antenna tower if you can't also make that a very repeatable process where it works most every time. And software automation and automating the use of drones is a key aspect of that. In the military space, hand-launched UAVs, one of the most common failure modes of them is actually the person hand-launching the aircraft. So the more that we can do to remove people from being highly involved in the deployment of drones and automate a lot of that with the software running on the drones and the software planning the missions and that the more reliable the solutions are going to be. The next is that they need to be compliant and insurable. It's not enough to have business value. Large enterprises, as they're thinking about investing in this technology and buying tens and hundreds and eventually thousands of drones, have to be able to insure those aircraft to the extent that they're paying commercial operators to come out and do surveying work on their power lines for their cellular phone tower and infrastructure. It's critical that those companies be insured and that those companies are compliant with the regulations that are in place today, and more importantly, all of the regulations, of course, that are coming out over time. The next thing that's important is that in most cases, the aerial data being collected by the drones is not a complete replacement for people being on the ground and doing aspects of the inspections themselves. And to the extent that that is true, it means that a lot of the same workers who are doing cell phone tower inspections today, who are doing power line inspections today, need to be the workforce that we're leveraging for doing aerial drone inspections as well. And that means being able to take an existing workforce, give them a new tool to put in their existing toolkit, and get them up to speed very quickly on leveraging that effectively. And that means minimal training. And software that's easy for just about anyone to use, user interfaces that are designed not for pilots and for engineers, but for utility workers, for construction workers, for power line inspectors. The next is that it needs to integrate with existing software and workflows. Right now, many of the solutions in the field are piecemeal. You see companies deploying drones, and they're taking the software and the data from one part of it, and then plugging it into a different software tool, and then to a different cloud storage tool, and then analyzing it with a third-party tool. And there's a lot of friction every time you're trying to move data around. That's all friction that is preventing greater and greater scale of use. Enterprises want that key data being collected by drones to be integrated into their existing workflows, asset management planning, and GIS software. Next point is that enterprises want to be able to scale the use of drones in a number of ways. First is use cases. A lot of businesses are looking at not just using drones for one application, but looking at using drones across multiple business units. I think GE is a great example of this, who are looking at using drones for everything from power line inspection to windmill inspection to inspection of key transportation infrastructure. And the drones need to be able to address a wide variety of applications. They also need to be able to scale in geography by being deployed over greater and greater areas of land. And they need to be able to scale in time by going back to the same site, like a cellular phone tower, and generating a time history so that you can easily see what were the points in time at which different pieces of RF antenna equipment were installed on the tower. And finally, I think is the obvious one, at the end of the day, it needs to be generating actionable insights so that the businesses want to invest and leverage this technology. Here's an example workflow that we've seen kind of time and time again to give you a sense of how a lot of enterprises are looking at using drones as part of a solution. The first thing that they're looking at is they're starting with planning. And planning involves a number of things. It involves establishing job criteria. It involves picking the aircraft and the sensors on the aircraft and other parts of the solution that's going to be deployed for data collection. It involves selecting the locations at which you want to collect the data and picking the operators and training the operators and getting them ready to deploy a solution. Then you need to get approvals, whether it's getting the insurance policies that you're going to need to deploy aircraft, whether it's getting approvals by a regulatory agency abroad or here in the United States eventually. And then you go on to collection, which means deploying people in the field crews that you may have existing within your company now, or finding service providers that you can pay to come out on a regular basis and collect data over your infrastructure. That turns into analysis, whether you're generating point clouds, 3D models, structural models, or conducting change detection. That involves a lot of different software tools which have been created in many cases to be industry specific or for a specific use case. You then need to integrate that data with existing data within your enterprise, whether it's EAM, ERP, GIS software, or CAD software that we're using. And ultimately, you need to distribute this in the form of insights via reports, maps, or some kind of output product to the rest of your organization. One of the problems we've seen is that as you're looking to do this for either cellular phone tower inspection or you're looking to do it for power line inspection, no two applications are really the same. There's a lot of things that are different. Take, for example, these two applications. For the power line inspection, you're going to start by using different aircraft. You typically want to use a fixed-wing aircraft for longitudinal inspections so that you can cover the distance required. But for a vertical tower inspection, you want something that can take off and land vertically, that's small enough to easily fit in the trunk of your car, and that can be deployed very easily. As we look at the power line inspection, the next thing you might look at using is a LiDAR for detecting where is the vegetation encroaching on the power lines. You might develop software algorithms or leverage software algorithms developed by third parties to actually automatically analyze where is the vegetation within a certain distance of the power line, so it's not eyeballs looking at a screen trying to determine where the vegetation is, but it can become a much more automated approach over time. And then ultimately, you probably need to integrate with some kind of existing systems like maps of the power line infrastructure, or you may be generating some of these maps. For the vertical tower inspection, you may be using a very different type of camera, a visual camera or an infrared camera, some camera that can assess the information you want from the cell phone tower. You may need some kind of special algorithm that actually flies the aircraft in a very specific way to capture and generate the correct type of 3D model that you're looking for. And you may be integrating with different type of mapping infrastructure to determine, and this may be private data, like where are all the cell phone towers that are owned by your organization or the organization that you're flying for, which are the ones that have guide wires, which are the ones that, what is the radius that you want to fly, what is the height of the tower, what are the regulatory requirements to fly and assess that tower, and so you'll want to integrate with that. These two applications have a lot of differences. What we've been doing at Airware is focusing on what is common between all of the different commercial solutions. And so we build a piece of hardware that flies a variety of different aircraft, connects with different sensors that are on the aircraft, software that are at a user's fingertips and in the cloud that can be modified and enhanced by third parties who can develop plugins for it that are specific to the applications people are looking to deploy, with a cloud backend that can be integrated with existing business and enterprise systems and pull in data from other sources. Here's a walkthrough. Planning typically starts in the cloud. This is Airware's cloud product. So you're typically going to start by organizing projects into something. This is the Greenfields client, where they have a couple of different jobs that are going on. If we jump into the field mapping job, we can see some more information. What are the most critical things here as we jump into this is that one of the first things you're going to do is you're going to create a geofence. The geofence is important because it bounds the aircraft to a volume of airspace when somebody else goes out and deploys that solution. And more importantly, it defines the airspace that you're not going to be flying the drone in, like adjacent properties. And so that gets defined here in the cloud. Other important aspects of this is that user authentication is built in throughout the entire system, as well as various profiles and things that you can do. So here, once you've built out the job in the cloud, you can then sign into the ground control station software, where different users can have different permissions. You'll see at the top that we have the Greenfields project, which has automatically been synced with the cloud, and the user, Jonathan Downey here, who has certain permissions. You can pull in automatically the job that we created in the cloud, and you can do certain things. What you can't do is change the geofence, which has probably already gone through an approval process, whether that be internally within your organization or whether it be externally with a regulatory agency. But you may want to do things once you're in the field, like change the takeoff location, so long as that is within the confines of the geofence. Here we've pulled in Field Survey 2 that's being looked at, and if something's in the way of your takeoff location, you may try moving that around, but if you try pulling it outside of the geofence, you're going to get a warning and not be allowed to do that. You may change the size or the area that you want to do the surveying over, again, so long as it's within the constraints of the geofence, and the flight path of the vehicle is going to automatically be updated and generated to achieve the amount of visual imaging overlap that you're looking to get. Complete within the software package is a high-fidelity simulation environment so that before you go out to the field, you can simulate any of the missions that you've created. Here we're connecting to a simulated aircraft. We have a flight package that includes this field mapping survey that we've generated. With the field mapping survey comes contingencies and geofences, which are the things that ensures the aircraft, no matter what happens, is going to respond in a safe way, whether it's low battery, loss of GPS, loss of RF link. They are predefined contingency scenarios so that you're always going to know what the aircraft is going to do. And here, it's being uploaded to the aircraft. You can see that the contingencies and geofences are checked. They're uploaded to the aircraft before it can ever take off, so that in the loss of complete communication with the aircraft, it's always going to stay within the geofence and it's always going to follow the contingency plans. Once you've uploaded that to the aircraft, it's as simple as coming down to the bottom right, clicking Activate, and then launching the aircraft. Right now, the aircraft is going to start taking off vertically. It's a multi-rotor that's being simulated, and then it's going to start tracking the flight plan that we've built. You can see in the bottom here, there's a plugin and widget interface. Here we're demonstrating the example of some plugins that have been created to mimic kind of typical aviation instruments that pilots might be interested in. But organizations can create plugins that are completely particular to their company, their organization, the type of inspection that they're doing. It may show the number of pictures taken. It may show the progress of the mission. It may show, it can generate overlays for the map that are particular to your use case. At the right, we're demonstrating a plugin that was created, which is a point of interest tracker, and another plugin, which is a manual control of the camera to take pictures. These are all plugins built leveraging a set of APIs that we will eventually expose as public APIs so that anybody can customize this software. Once you've flown your mission and you've collected all of the data, all of this is automatically synced to the cloud the next time you have internet connectivity, so it's not required that you have internet connectivity in the field. What we found is that in many cases for industrial inspections and agriculture, there isn't 3G and 4G and LTE connectivity in the field. All of the pictures get synced with the cloud, but more importantly, or also importantly, the metadata associated with where the vehicle was, all the other metadata associated with the aircraft, and then you can export that into tools like Pix4D, which has been one of our launch partners, so that you can generate a point cloud as an output of that. Here you can see in the point cloud that it's very detailed. I think a lot of you are probably very familiar with Pix4D, but you could then assess anything from the water level in the creek to where there are tire tracks to maybe even the depth of the tire tracks. You could also export the data in an increasingly seamless fashion to different data analysis tools, either data analysis tools your company is already using, or ones maybe even that you've built out internally within your company and are proprietary. So as a quick summary, I wanted to just touch on what are some of the areas where I see some significant opportunities. It's really almost across the board. A lot of companies are looking for better tools to help them build out a complete solution. I think there's opportunities for companies building complete solutions for different verticals and industries and taking the aircraft, the data analysis tools, the cameras, and packaging all of that together in a way that's tailored for a certain use case. Developing better interfaces with regulatory agencies, insurance offerings, companies that are focused on being the service providers. In many of these cases, it's not going to be the farmers who are buying drones and using them themselves, but service organizations that they're calling who are going to come out on a regular basis and do the inspections. All kinds of opportunities, both with existing and new data analysis tools so that different insights can be generated, again, often in ways that are specific to different industries and use cases. Integrations with existing infrastructure that are in a lot of these enterprise organizations or within your own, and ultimately the generation of the maps, reports, outputs, and insights. And with that, I'll thank you very much for having me speak today, and I'd be happy to answer a few questions if there's time. It's certainly the case that a number of companies are looking at using infrared cameras or are already using infrared cameras from manned aircraft to assess areas of the power line, like the insulators that are warmer because they are not perfect insulators anymore and actually letting electricity conduct through them, which is raising their temperature. So infrared cameras is the one thing I know about that people are using today. Sure. So we decided to make our business model subscription-based because we're very interested in aligning the costs of deploying drone-based solutions with the ability to generate ongoing revenue or cost savings by leveraging them. And so that was a key aspect of why we decided to go with the subscription model. The other is that we want, like a lot of other enterprise software companies, to fund continuous development and improvements to the software that our subscribers are signing up to use. And so the subscription is $2,500 a month per drone. $2,500 a year per drone, not a month. If you guys want to give it to us a month, that's fine too. We won't object. And that's for the hardware, software, and cloud services. So that complete end-to-end solution that helps you go all the way from the planning stage to the output of insights and reports, and is built in a way that it's a platform so that you can leverage or build your own tools that are specific to your use case or application. Okay, thanks so much for having me.